Okay, so this is our video for 1/6, the review of the trig functions. So you're looking at the PDF where we organized the 6 trig functions in an array, and we want you to use this array moving forward. So the left column, we have sine, cosine, tangent, and we wrote them that way because the definition of tangent is sine over cosine. And across from them are the reciprocal trig functions. The reciprocal of tangent is cotangent, the reciprocal of cosine is secant, and the reciprocal of sine is cosecant. Then in this column, we wrote the definition in terms of the unit circle. So in the unit circle, the sine is the y. That's where the radius is 1. And if we do a size change of that, we'd end up with y over r, depending on what the radius of the image was. Cosine's x over r, sine over cosine, the r's reduce out, tangent's y over x, and there's the reciprocals in the other column. And then in the triangle column, we have the definitions by SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. For tangent, opposite over adjacent, and then you have the reciprocals. Okay? So in the textbook, example 1 is on page 47. No, 46. It says, find the length of an arc on a circle of radius 3 by a central angle of 2 pi over 3. So there's multiple ways you can do this, but the procedure is more important than the answer. So what we did was say the circumference by definition is 2 pi times the radius. And in this case, the radius is 3, so the circumference of the entire circle would be 6 pi. But you don't have the entire circle. You have 2 pi over 3 of 2 pi. So I just multiplied 6 pi all the way around the circle by 2 pi over 3 divided by 2 pi, which we rewrote as 2 pi over 3 times 1 divided by 2 pi. 2 pi's reduce, 3 reduces into 6 pi, and that would be the length of the arc. Under those circumstances would be 2 pi. Okay? So we're going to ask you to pause the video and go to problem number 1 in the exercises, and then compare your answer to what we got. So for number 1, the radius was 2 and the angle was 5 pi over 8. So all the way around the circle would be 4 pi. You multiply that by 5 pi over 8 as a share of 2 pi, and you'd end up with 5 pi over 4. Okay? The graphs of trig functions in your book on page 47, I didn't really reproduce that. Or periodicity, the heading on page 247, I'm going to go right to even and odd trig functions. So the sine, ready? 2n, add or subtract 1, is the way of writing an odd number. 2n's an even number. Take any integer, multiply it by 2, you get an even number. You add or subtract 1 from an even number, you get an odd number. So the sine wave, and the picture's on page 47, is an odd function, and the cosine wave is an even function. Okay, and the way you think of an odd function is when you go to the left, you get the opposite magnitude, the opposite height if you went the same magnitude to the right. And for an even function, when you go to the left, you get the same height as if you went the same magnitude to the right. Okay. So example number 3, they tell you the sine of theta is -3/5, and they tell you you're in quadrant. Well, they don't tell you that. You know that the sine is negative in quadrants 3 and 4. So they also tell us the tangent is negative. Well, the tangent's negative in 2 and 4. So therefore, what do those two things have in common? Quadrant 4. So go back to the array from the top of the PDF, and we reproduce the array, and where there's a sign, we write -3/5. because the sine's y over r. Well, you have a Pythagorean triple. 3 squared plus x squared equals 5 squared. So x equals 4. So the cosine's 4/5. The tangent is sine over cosine. So you have a negative. The 5's reduced, and you get negative 3/4. And to the right, you have the reciprocals. Okay? So that's your model. You pause the video and try problem 9. So for 9, you have another Pythagorean triple. So they tell you the cosine's negative 15/17. The cosine is your x. So the cosine's negative, you're in quadrants 2 or 3. And they tell you the sine, the y value is positive. So you're in quadrants 1 or 2. So therefore, what they have in common is quadrant 2. The cosine is x over r. So it'd be negative 15/17. And what's missing is the y, Pythagorean triple, that would be 8. So y over r would be 8/17, and then you just fill in the rest of the array. Okay. So for transformations of trigonometric graphs, we just want to point out to you that the way it's explained in your textbook, we're going to ignore. The way it's explained in your textbook corresponds to the way your calculator does this if you go here, which we are not going to do. On the calculator, if you go to Stat, Calc, you will see sine regression here. So if you, in regression, it's like Jeopardy. You tell the calculator the points on the curve, and it'll fit a sine wave to that. But this won't make any sense to you because they're using values that are not familiar to you, how we learned it from the Chicago book. Okay, so the way we're used to doing this is a transformation of slide of h comma k following a scale change of a comma b, where a and h correspond to what happens to the x coordinate, and y and b correspond to what happened, or b and k correspond to what happened to y, and we do the opposite to achieve that. So we're going to ignore in the textbook the way they refer to transformed sine graphs. They're not on the homework. We're going to do it the way that you're familiar with it, which is more user friendly. Okay. So here's a transformation, example 4. In example 4, we're on page 48, and all we did was rewrite the question, except we took the 3 and divided both sides by 3, and we factored the 2 from inside the parentheses, put it out front, then we have to factor a 2 out of the pi, and we rewrote the 2 that's being multiplied by the numerator as being divided by 1/2. But this is all in a format that you can identify what the magnitude of the transformation is. So this is the important part of the problem right here, to rewrite the question in the book. So if we look at this, ready? Your a is 1/2. Your x has been expanded by a factor of 1/2, so you did the opposite. You divide it by 1/2. Your y's have been expanded by a factor of 3, so you divide by 3. The slide is pi over 2 to the right, so you did the opposite, up 1. So here's the magnitude of your transformation. It is a slide of pi over 2 to the right, up 1, following. The open circle is following the scale change of magnitude 1/2, 3 to this pre-image. So the pre-image has a period of 2 pi. Well, the period's affected by the a value, so 2 pi times 1/2. Your image has a period of pi. The domain is not affected. The range of the pre-image goes from -1 to 1. So what happened to that? Well, it's affected by the scale change, which was 3. So now the image has a range from -3 to 3, and then you're sliding it up 1, so the range of the image is -2 to 4. So in order to graph this, instead of typing the whole thing in the calculator, we had this preset in Y5, which could be set to cosine or sine. You just type it over. And we store the values. Pi over 2, store above the on key, alpha h. So we'll go over here to show you the beginning of that. Pi over 2, store above the on key, alpha h. And then if you separate the terms with a colon, you can do it all in one line. Okay? So then we put all the values in here, and the output is just going to be the last value typed in. Then the window has to match up. We just made the x min and x max negative pi to pi. We already knew up here that the period of the graph is going to be pi. So we're going to see two periods of the graph. We went from negative pi to pi. And then we use this range for the y values, and there you see two periods of the graph. Okay, so that's your model. What we're trying to do is associate the question with the pre-image and understand the magnitude of the transformation, not just type this in the calculator and see what it looks like. We're typing it in the calculator just to confirm that we did the analysis correctly. So you're going to pause the video and go to problem 13, please. Okay, 13. And again, here's the issue. You take the 3 that's inside the parentheses and you factor that out. So if I were to distribute this 3, redistribute it, you get 3x plus pi, which is what was in there. When you take it out, you got to divide both terms in here by 3. And multiplying by 3 is the same as dividing by 1/3. But now we see the magnitude of the transformation and how it affects the period, and the domain, and the range. Okay, and the period of the pre-image, the tangent, is just pi. So the period of the image is pi times a, which would be pi over 3. This modular is just saying x can't equal pi over 2, add or subtract pi for the pre-image. For the image, x cannot equal pi over 6, add or subtract pi over 3. Okay? And then we stored those values like we did earlier. And you get that picture of the graph. It's not a very good window, but we're more concerned about the transformation. Okay? But the inverse trig functions. So what happens is, because the trig functions are not one-to-one. They're functions, they pass the vertical line test, but they fail the horizontal line test. But if we put a restriction on the domain, then it would pass the horizontal line and vertical line test. And the restriction we put on the trig functions is for the sine and tangent quadrants 1 and 4, negative pi over 2 to pi over 2, and for the cosine, 0 to pi. So it's once when it's positive and once when it's negative. So when you do that, here we have the inverse sine graph, because what happened? Domain goes to range and range goes to domain. So for the parent graph of this, the sine wave between negative pi over 2 and pi over 2, that would be the domain, and the range would be negative 1 to 1. For the inverse sine, the domain goes from negative 1 to 1, and the range goes from negative pi over 2 to pi over 2. Okay, and then that's example 6. Problem 25. Here's a graph of the inverse cosine. Okay, so hopefully that it's a very dense section with a lot of review from pre-calculus in there in one section. But hopefully that reminds you of what you did in the previous course. And additionally, we didn't do this in the section, but there are Google Slides in the Chapter 1 folder for the sine and cosine of alpha add or subtract beta, which is important. We use that later in the course. So if you don't necessarily remember what the sine of alpha plus beta is, or alpha subtract beta, cosine of alpha plus beta, cosine of alpha subtract beta, there's a Google slide that walks you through those derivations. Okay, thanks.